All right, good day. So I'm planning on doing the LeetCode contest I missed from Saturday afternoon. Let me share my screen here. Okay, so let's see. It'll be contest 299 that I'll do virtually. So I did bi-weekly contest 81. I was kind of bummed that I didn't get the third question. It was a pretty simple one, just the bitwise OR of all values accumulated. But anyhow, day I'll focus on weekly contest 299 and hopefully believe in myself and get on to that Q3 and Q4 and hopefully get 3 or 4 solved. At worst case, I missed them all, so let's see what happens. Whatever, do my best. Okay, so here we go. Open these guys up. Check matrix, X matrix, square matrix, X matrix, both the conditions hold, all the elements and diagonals of the matrix are non-zero. That diagonal is good. That diagonal is good. Okay, all the elements are 0 other than the diagonals. Okay, so the weird thing about diagonals, there's 2 of them here, but whatever. We should be able to just code this, right? I'll do it in Python 3. So 11:42 a.m. Minutes for implementation. Python 3. Okay, so we're going to go through, and is the length of, let's see, is it in by n? It is in by n, okay. For I in range n, G will be our column in reverse. We'll go, as we go down, we'll go across that way. So J will be, I will be left pointer, J will be the right pointer, and they'll just slowly go down and check them all. If it's good, it'll return true at the end, otherwise it'll return false at the first instance of failure, the first violation to the constraint there. Let's see, so all the other ones need to be 0 though, other than what's been seen. So let's do this. Use seen as a set of what we've seen and just make sure all the other ones are not seen. Okay, so that'd be a subtuples ig that's been seen. Seem to add ij as a tuple. Yeah, it should be okay. N minus 1 minus I, since j is inclusive. All right, and then if not a sub I, so see the kth row, how about okay, that equals k is right. The kth, wait, this is kth row. This is kind of weird. Actually, let's do the ith row. Let's do j is this guy, and then k is the other guy. Oops. K is the other guy. So a sub I sub j is the left one, or not a sub I sub k. False. Otherwise, let's see, we'll return all x for x in row for row in A. I want that x to be 0, not x. Let's do this. I row and enumerate A. Jth column of that row. xj. J underscore is fine for row IJ in the scene or not a sub I sub J. Okay, that's what we want. Oh, syntax. Row is not defined. I mean, pal. Oh, I row. Does this work? So Python 3 is a little bit strange, and then it's you have to like write this backwards. Oops. From right to left. Syntax doesn't like that. Okay, I might not make this fancy and concise my first pass. Basically, I want to make sure that the tuple IJ is seen, or oh, let's do this. Make it easier on myself, right? Let's do this just for J in range and for I in range and false, but it should be true. Let's do this. E equals lambda IJ. Return the formatted string of IJ. Seem to add the oh, it's not IJ, it's KJ, right? Or JK. JK for this guy. IJ. Okay, so that's a bug of my mistake. No, it's still false. What the heck? I'll just print this. That doesn't help. Okay. Oh, so okay. EIJ. No way. Really? Should. The technology is easy, but this one goes backwards. Yeah, as I increases, that goes backwards. It's fine. Let's see. Let's just return true here. Okay, so that is fine, that check. But then the zero check is not okay. I'm gonna officially check for all the zeros that are on the diagonal, right? Just do it this way, the long way. That can be fancy. I say P. Let's consistently call this one J and call this one K. JK scene or now face of J to K. So that is not, he is not in the scene. And JK, the one return false. Is return true. Oh man, okay, so where is this violation? Failure occurs at Oh wait, these are relative. Oh crap, these are relative offsets, not necessarily the IJ column. So I totally confused myself. Okay. Oops. All right. Wait, no, is that right? I threw a Keith column. No, that is right. JK. Oh no. We've seen two things, right? We've seen, yeah, this is right. Okay, so we've seen IK or IJ, and we've also seen IK, right? Okay, so then, okay. Yeah, so that was good. That was the problem I had. Okay, so then we can shrink this up, but anyhow, it should be accepted. I'll clean it up a little bit. This one's true, that one's false, right? Okay, so that was good. It's accepted, and then we can clean it up. So return all EJK in scene or not a sub J. Let's just call IJ, it's fine here. J for J range in for I range in. So that's backwards in Python. We do it from right to left. That's good. Okay, so that's cool, and that's pretty concise, right? The ith row, and then the 2 pointers J and K, and that took a lot longer than I was hoping. 11:53, so 11 minutes for the implementation in Python 3. It is a pretty decent solution though. So let's write this real quick in the other languages. It shouldn't take that long. Few solutions. All right, so for each, let's see, iterate the through the diagonals one row at a time. Left. J and right first with initial leftmost column J and rightmost column K. To ensure the cells seen are non-zero. Then ensure each not seen cell is zero. Oh, that's good, right? So Kotlin, JavaScript, Python 3. Oops. Stick that there, and then C++. And then maybe do Rust too. That should be good enough. Okay. Oops, maybe okay. So n equals a dot size for I throw from 0 to n minus 1 inclusive. Let's J be the leftmost column, and then K will be the rightmost column inclusive, and then we'll have a set of scene values. Actually, let's do this using scene as an unordered map, so we can take advantage of default constructor. Oops, unordered map. Cool. To take care of what's been seen as by default false, and let's say scene sub I sub j was true. Scene sub I sub k is true. And if not a sub I sub j or not a sub I sub k, return false immediately upon a violation. And then for each cell that's not been seen, if not seen, a sub I sub j, I cell j, I row j column is not seen, and a sub I sub j is a non-zero value and return false, otherwise return true. Okay. That looks good. That's accepted. So there's a way we could do this functionally, but it'd be a horribly verbose solution in C++. So that's good enough. And that's cool. Let's do this in JavaScript. See, is a new set, and then key will equal scene value for the cell ij. Okay, so n is the length of a, I is, let's see, then 0 to n minus 1 inclusive, each ith row, that j the leftmost column, k equal the rightmost column, and if a sub I sub j is 0 or a sub I sub k is 0, then return false upon the violation. Otherwise, seeing that add key ij and also seeing that add ik, and then over each cell, make sure the other ones are actually 0. Let's do this. Actually, we'll do it functionally because it's way shorter. Arrays of n dot keys for 0 to n minus 1 inclusive, and we'll map each. Let's see, how does this work? Each ith column to an array of keys, which is destructured, and map to each jth column. Seeing that has key ij or every map scene or piece of ij is a non-zero value. Looks good. Oh, dang. Okay, there's a bug. Every oops. Okay, something's wrong with that one. Every this to every ij is cool. Oh, every keys of every chain. Oh, or not. Oops. Right, you want that to be a 0 value. No, that's not right. So the first one should be true, and it's not. If the diagonal is 0, return true. Otherwise, either seen the diagonal or it's not zero. Seen that has, oops. Okay, seen that has, so I did that wrong. True, false, false. That looks legit. Okay. Stick that there. Now let's do it in Kotlin. Array and oops. Data size and for I and 0 until n. J is I, K is the leftmost column, rightmost column. So if a sub I sub j is equal to 0, or a sub I sub k, oops, k is equal to 0, return false immediately, otherwise we'll add the value to scene. We will set of strings key equals lambda for the cell ij, which is mapped to a string j for us. Scene that had eij, and then scene that had eik for each cell. And 0 until n, and j for the same. Well, actually, let's do this. Instead of traditional, just do int arrays of n, so it dot all. Let's see, we want to map it to each column. So j. Scene dot has the key ij, or a sub I sub j is not equal to 0. Okay. O contains false, false, oh. Okay, let's see if it gets here. Here. So the first one should be true. Print, oops, print when okay, so it is failing early. So equal to 0. So it's not right. N minus 1 minus I. A sub ij equals 0 or a sub ik equals 0. Then we're turning false. Is N minus 1 minus I. Looks okay. Is okay. So what row is it failing on? Come on. Okay, so which one? Nope. Okay, hold on. I want the output for this. Oh, okay. It does get back to this. So it's failing as the next step. scene contains the ith row j column or a sub ij, oops, is equal to 0. Okay, cool. That's what I wanted. Okay, and then the other test cases for true, false, false. This is what I'm expecting. Looks good. Looks good. Okay. Kotlin, JavaScript, Python 3. I don't know if I need a rest or not. Yeah, whatever. Let's just do it while we're here. Okay. And equal a dot length for I in 0 until n non-inclusive. That's equal j equals I. All right, now it's doesn't need to be beautiful. Wait, yeah, it does. No, it doesn't. It doesn't. And minus I. Okay, so leftmost column, rightmost column. Then if a sub I sub j is equal to 0, or a sub I sub k is equal to 0, and return false immediately. Otherwise, we'll have a set of scene hash set use the collection. Then let's do u equals j cell. Format the string ij. Okay, and then that and key ij, and key ik, and then we'll return 0 to -1 inclusive. Does Rust have an all? Just all? Any all is a closure. Okay, yeah, it does. All. All j. Scene that contains key ij or a sub I sub j is equal to 0. Okay. Collections, today collections. Add is not insert. Insert contains key, I think is for the hash map. Add a reference to that guy to borrow it. Oh, seeing it, okay, I want it to be mutable. So you can insert into it. True, false, false, big money, no whammies. Here we go. Yay. Okay, that wasn't too bad. I am improving slowly with Rust. So, okay, that's the deal. And yeah, that's cool. That's all she wrote. Q1 took half an hour, dang. Oh, well. Oops, what is this? Okay, this is my solutions. Okay, Q2. All right, 1 hour remaining contest. Okay, gotta go faster. Okay, so all plots are empty. There's n times 2 plots where there's street with n times 2 plots. There's n on each side of the street. Okay. No two houses are adjacent to each other on the same side of the street, so all plots are empty is always possible, I guess. A house is placed on one side of the street. On each side of the street. N equals 1. Okay, so n equals 1 would supposed to be like the base case. One side of the street, other empty, or two houses. So we have an arbitrary amount of houses which you can place as long as they're arranged distinctly. So there's 9 different arrangements. Example 2, empty. One side of the street, the other side of the street. And then n equals 2, so there's 2 positions. They can't be adjacent, so you can't have one here. Oh, it's 4. There's always 4 for each cell. There's 4 for each cell times 2 plus 1. Okay. Okay, so KISS, right? Keep it super simple. 4 for each I position plus 1 for empty. Does that work? I don't know. Let's see. So return 4 times x plus 1. 5 and 9. Okay, so that's not right. Oh, wait. Okay, so it's not that naive, then, is it? 24. Okay, so yeah, it's not super naive like that. Okay. Hold up. Hold up. Actually solve the right problem. I need to actually read it, right, and understand it. Okay, so let's go begin. So we'll DFS it and consider all possibilities and then memoize it. Right, so it's dynamic programming. We do top down first and then bottom up next, I think. And then 29 using the rule of product. So all the places of this one times all the placements of the next one times blah, 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 blah. So basically using combinatorics. Combinatorics is just a fancy word for counting things. All right, so we got 1 here, but then you can't have 1 there. So how am I going to check that you can't have 1 there? So we'll check for each. You have a top and a bottom. Make true or false for the last one. To restrict the next one. Which is up and down. So it's +1 for the empty case, right? +1 for that, right? And then if I is equal to n, return 0, that'll be the base case. So we can make a house placement above if there was not one previously above. And then we can make a house placement below if there wasn't one previously below. So does it ever make sense to skip a house placement? I don't know. I don't want to count this thing then. Okay, so one here, one there, one both there. So +1 if the previous one wasn't set, and +1 for the previous one that's not set, and +1 more if both of them are not set. Set the first one, set the second one, or skip them both, right? So A will be setting both, or the upper one if you can. Otherwise, we'll skip it. Right, so it'll be the previous one wasn't set. And not the last of. Plus if it's set to the next one, go I+1, true, D whatever it is set to, keep it as it is. One is set. Let's do this 1 plus that. If not, you. Otherwise, if you is set at 0, B equals 1 plus go, I+1. This is down is set. So the same thing for that. If not DL 0, and then C equals 1 plus go plus 1, true, true. If not U and not D, plus 0. Return equals 99 plus 7. Equals 0, say. Or Y in ABC. X equals X times Y modulus mod. This will be A. Multiply A by B and C, and then return it. Okay, let's see what happens. Answers 2 and what? And 2, it should be 4 and 9. Okay, so this is way off. So I'm wondering if I'm writing the recurrence relation right or not, but obviously not right. Excuse me. We need to add those up then, right? Okay. All these ways times the next one. One position here, one position there, and then that one. And then for this one, there's one position there. Oh, there's empty as well. Okay, so I'm gonna return one here, right, for the empty. 9 and 2, that doesn't look right. That's not right at all. Oh man, okay, so here's about where I probably stopped believing in myself. It took me about 13 minutes so far to know starting this thing. Right, it's been about 13 minutes. 13 minutes so far for implementation, which doesn't work. Not at all, really. Okay, so how can I model this where it's simple to track, right? So you either don't have one here, you have one here, don't have one here, you have one here, and then you have both. I'm pretty sure this thing's symmetric, so I thought I could multiply by 2. That's not right because it's kind of straight. Yeah, so this one above, this one down below, or skip it. Skip it all together. Just skip it all together. I didn't consider that one, right? So let's do this one. This will be B, C, and D. A, I'll be skip it all together. Last one was not set for either. Skip the whole thing. As long as the last up was not set, then. Oh, wait, hold on. We don't want to have one here. When we bottom it out, the base case, that's when we'll allow it to accumulate and unwind. right? So just don't want these. Term one was the base case, right? We reach, that's a way to reach it. And after you reach it, okay. So let's go on. That is not, still not even close to being right. Times. So I'm pretty sure it's a zero, right? So if not y, continue out of that thing. Right, it's just we don't want to include that option. Okay, so this is not right. Okay, so let's see, n is this big. Probably just stick it in an array then, right? Maybe bottom up in this case is easier than top down. Keep it super simple. So this one is, it's a 4, so it's not as complicated as I'm pretty sure I'm making it. Only ways you can place one house, which is nothing, 1 or 2, nothing, 1 or 2, nothing, 1, 1 or 2. Yeah, so let's do this. Oh gosh. Yeah, I'm totally confusing myself. So here, let's just think about this over again here. Does it make sense to do top down or bottom up? I think bottom up maybe the way to go, but then how would I model the recurrence relation? Like how would I keep track of the previous and the current? And you keep track of the number with and without to the top and the bottom. Right, let's try to verbosely do this then. Each item, top or without the bottom in this number of ways. And then with both be included in those widths and withouts. Okay. Stay positive and KSS. Keep it super simple. So keep track of the top and bottom in this thing, whether there's a house there or not, and then an ongoing count. which we can accumulate onto, is the previous placements multiplied by the current placements. It makes sense to do it from right to left then in that case, right? So we can put the base case over there. So I'm kind of thinking this top down, I'm kind of thinking right bottom up, and I'm totally confusing myself along the way. I equals in, then we found one placement. So let's do include top equals top false, bottom false. Let's do that. Okay, so include top equals if not top, if not previous top is not. Or let's do this. So if I is less than 0, n minus 1. Wait, hold on. Yeah, let's keep this simple and minimize it later, right? Trying to do too much at once. Start from top down and try to go bottom up, right? So if not top, else it doesn't count, right? Top is adjacent, you can't count it. So include top would be go I plus 1 true, and then whatever the bottom is just my matter. Exclude top, exclude top. Let's go I plus 1, whether no, this would be false, explicitly false. If not, so wait, it doesn't matter if the previous top was set or not. Include bottom, it's good. This one, where the top was and the bottom was true. If not bottom, otherwise 0, we can't include it. Exclude bottom is good at this one. Top false. Explicitly excluded. So if they're both included, it's taken accounted for. Okay, so then we want to multiply all these things. All right, so product equals as long as it's one of them, that or as long as one of these are non-zero. It has to be non-zero, right? One of them has to be non-zero because excluding all of them will end up at the base case eventually. So that's safe. Okay, so return product at the end. Okay, and then return go. Okay, product. So prod equals product times include top modulus mod include bottom. Wait, include or exclude, exclude top and include or exclude the bottom. Exclude that. Include the top, exclude the top, include the bottom, exclude the bottom. Something like that, right? Maybe no. What? Oops. Okay, that's not right. Now I suppose I might be at the place where I'm just throwing things up on the wall to see what sticks. So initially the top and bottom are both false. Number of ways. I don't follow this right. Because I need to accumulate them and then multiply them. Accumulate sum of house payments current. Exclude top and bottom is one way. Including the top is another way. Oh man, yeah. So this one's confusing. I'm not making progress. It's been 30 minutes. I'm gonna solve this one. So it's been about 30 minutes, and I'm totally spinning my wheels on this one. Let's move on. It's painful, but welcome back. All right, maximum score of sliced array. So given a zero indexed arrays, you choose two integers left and right and swap the subarray. Already. Do once or do nothing. The maximum possible source. What is this? Swap 60 and 90. Okay, so we want to maximize one or the other using okay, this one looks like a sliding window. Right. Okay, so let's check this one. Let's get back on track. Stay positive here. Come up with a good game plan and make sure it's solid, and let's implement it. So the game plan is to use a sliding window. Let's see that I use an immersion and use inversion to take the largest difference. Largest difference. So actually, does that look right? Difference here. Let's look at this. Okay, I'll focus and stay positive. Let's see. So this guy. Anyway, so we saw the last two. So we can swap the inside of one or the outsides of the other. This one doesn't seem that hard, but I'm still kind of flustered and worn out from the last one. Q2 took a lot out of me, unfortunately. Maximizing one is minimizing the other. Is it beneficial to swap? Is it not beneficial to swap? Oh man, yes. What do I got? 27 minutes left. Okay. Undirected connected tree and nodes. Yeah, this contest is hard. I'm having a hard time with this one. That's gonna hope maybe I can see one of those other ones, but this one, I'm pretty sure this one's a sliding window, right? So we want to minimize one, maximize the other, right? For some Sabre. Slice. Yeah, I'm worn out. 25 minutes left. Actually, I can take a break. Harry, I know my little doggy. You know, buddy. No, the hard part. Hey, bud. You take a break with me? Yeah. Ay, ay, ay. Oh, excuse me. Okay, so yeah, okay, this one that doesn't suck. It doesn't suck. I kind of suck. So I have a significant room for improvement. This one's a super humbling contest. I'm really glad that I participated in it. I'll be glad when it's over, I think, too. Yeah, whatever. Let's try this. Yeah. Hmm. A. Hmm. Yes. People fast is slow and slow is fast, and I am part of people. It is inclusive of me. Actually, hold on. I'm cooking a hamburger, so I gotta listen for the timer. Hopefully, I don't burn it. All right, so let's do this. For who I don't know how to do it in loop really. Let's see. Int I equals 0 as its name. I think that's good for j equals I, and k equals n minus 1 minus I. I think this works in Java okay like that. And then if a sub I sub j equal to 0 or a sub I sub k is equal to 0, then we'll return false there. Otherwise, let's see, unordered set Java, unordered hash set. Sounds good. Let's use a hash set. Hash set of strings. And then, okay. Nope. Hold on. Hash set string scene equals new hash set scene add PIJ. We define a lambda. That'll be a string that returns key and be given integers I and j, and it will return. Let's see, Java string format. Method formatter to format. Holy cow. This is really ugly. Oh, actually, strings in Java, I can just make a string very easily, isn't it? Using the plus. I dot to string plus comma plus j dot to string. So I think that's probably okay. All right, and then for j equals 0 as a snan, I for int j equals 0, j is a snan, j. If not seen that contains key, oops. Key ij and a sub I sub j is equal to 0. And return false here, otherwise return true. Something like that. Key string is now a functional interface. I was learning how to, I was reading this book, Modern Java in Action, and they had some lambdas in here that I wanted to practice. Not that you could define a lambda like that. Hold on, I'll be right back. I'm gonna flip my burgers. Compilation error, can't find symbol key. String is not a functional interface. Oh, I do want to define a functional interface though, right? I think I want a functional interface at least. Define a lambda itself though. Let's look at my notes. Let's see. Got this hello world thing I've been messing around with. So I'm not actually ever defining a lambda directly here. Yeah, still learning Java, and this is not looking so hot. Let's see. Java lambda function. Let's see what we got here. And Java is extremely verbose. Function. Is that what I want? It's function. Function. Functional interfaces. With function. Let's do this. Java lambda function as a variable. No, I want a consumer or integer. What? Consumer. Oh, interesting. Consumer, okay. Consumer string. Incompatible types in lambda expression. Consumer, interesting. Consumer, but I want to pass it in. Oh, is it consumer interface? Let's see. Does it matter if it's returning and integer? One required. Well, we'll pass in two though. All right, yeah, my burgers are ready. I'm gonna take off and eat those. But anyhow, I have a lot of room for improvement. It's super cool that I got one of these. Could be worse. That could be better for sure too. Whatever. Cheers.